Today experiment name is realization of SR and D flip-flop using logic gates. So first of all we design the truth table. Set, reset, then present state. You know, as the flip-flop there is memory code and next state. Set we represent as S, reset R, present state suppose it is Qn and next state Qn plus 1. Then we draw the circuit diagram. We use 4 NAND gate. This is S, this is R, Q bar. So this is the circuit of SR flip-flop. Let's see. For 0, 0. So Qn 0 and Qn plus 1 also 0. For 0, 0, if the present state is 1, next state also 1, no change. For 0, 1, if the present state is 0, for reset it will be 0. For 1, 0, if the present state is 1, as the reset it will be also 0. Next combination, this 0, 1. Next 1, 0. If the present state 0, for the set it will be 1. If the present state 1, it remains same. Next for 1, 1 condition, if the present state is 0, next state don't care, and for 1 it also don't care. It is called indeterminate. Indeterminate. It is also same. So you can see there is no change. So far no change. For these both are 0, so it is called reset. This is called set. So what is indeterminate? Just calculate. Suppose we assume that it is 0 and it is 1. So for 1 and 1 condition, it is clock pulse. I will discuss this later. For 1 and 1 condition, for clock it is always 1. Okay. So for 1 and 1, the NAND gate it will be 0. You know, for 1.1 it will be 1 and that complement equals to 0. And as it is 1, so 1, 0, 0.1, that means 0, and its complement equals to 1, so it is 1. You can see it is 0, but now it is 1. Now it is 1. So it come to this side 1, and for this we get 0. So for 1 0 we get also 1. So both q and q bar should not get same value, so it is called indeterminate. Now we sort out this truth table, summarize. If we summarized, suppose it is input, it is output, inputs are both S and R. So for 0 0 condition, output suppose Qn. For 0 0 condition, we can see it is no change. For 0 1 condition, it is reset. For 1 0 condition, it is set, and for 1 1 condition, it is indeterminate, so you can say it is rest condition, RC. Why it is called rest condition? Because we don't know which gate do the faster. Now we come to the circuit. For clock pulse, actually there are two types of triggering. Number one, level triggering. It is called level triggering. We use here edge triggering. Two types of edge triggering are there. Suppose this is high and this is low. If the edge going to low to high, it is called positive edge trigger. This is positive edge trigger. And if the pulse go from high to low, it is called negative edge trigger. So we use positive edge trigger, so it is the symbol of edge trigger. Now we give the pin number for this circuit. As we use only one type of gate, NAND. We know the pin diagram of NAND. One, two inputs, three output. Next, 4, 5 input, 6 output, 7 for ground, 14 for VCC, that is plus 5 volt. Next 13 12s are input, 11 output, 10 9 are the inputs, 8 output. The IC number is 7400. It is quad 2 input NAND. So first we see the pin number and get the pin number into the circuit. So it is the first gate. We assume it is the first gate. 1 2 1 2 3. Next 4 5 6. So 4 5 6. Next 13 12 11, or you can take 10 9 8. 10 9 8 13 12 11. So we get the Q output from 11 and Q bar from 8. So it is the SR flip-flop. Now to overcome this stage, this race condition, we can design D flip-flop now. Zero, 0, 1, 1. So for 0, if the present state is 0, then the next stage will be 0. For 1, it will be 0. And for 1, if the present state is 0, it will be 1. For 1, it also 1. So if we summarize this truth table, we get the truth table, that is input, it is output, it is D, it is Q, and suppose. You can see there are two stages, 0 and 1. For 0, we get argument 0. And for 1, we get argument 1. So it is the final truth table of the D flip-flop, this one. So we just connect a NOT gate to this circuit. We know the pin number of NOT, 1 input, 2 output. So it is called the D flip-flop. Circuit will be same. So let's check the circuit in the gate. Okay, this is 7400 IC, 2 input NAND. Now we design the circuit. First we design SR flip-flop. It is plus 5 volt. We have to connect to the pin number 14. This is ground. We should connect to pin number 7. So first input, that is S, we connect to the pin number 1. Next, another input, that is R, we connect to pin number 5. Next, there is a clock pulse. We connect 1 Hz clock from the kit to the pin number 2. Pin number 2 and 4 are shorted. We short the pin number 2 and 4 by the connecting wire. Next, as per circuit, pin number 3 and 13 are shorted. Pin number 3 and 13. Next, pin number 6 and 9 are shorted. Next 10 and 11 shorted. 10 and 11 are shorted. Next connection 12 and 8 also shorted. So it is 8 and 12. We get the output from pin number 11 and 8. It is Q from pin number 11 and it is Q bar from pin number 8. Now we switch on the kit. How we check the flip-flop circuit? Okay, first of all, it is S, which is going to pin number 1, and it is R. It is Q and it is Q bar. So if we give the R 1, then it will be reset. That means Q bar will grow, Q will be off. And for 0 0 condition, it will no change. If we give 0 0, it is 0 and it is 0. You can see no change. Previous state stored in the memory. Okay, last S will be high and R will be 0. So it is Q will grow as per truth table, and for 0 0 condition it will no change. So the circuit is working. And the last stage, that is 1 and 1, what is it? It is S condition. You can see it is S condition. If you give the high frequency, you can see it. Okay, so this is the SR flip-flop. Now we design D flip-flop. So for D flip-flop, we have to connect another IC, that is 7404 NOT IC. For NAND, we get the 4 gate, we use the 4 gate, so we have to check the 4 gate of the NAND IC. And for NOT, we use only 1 gate, so we have to check the 1 gate of the NOT IC. So first we open the input. The circuit remains same. First we short the plus 5 volt, that is pin number 14 and 14 will be shorted. Next, pin number 7 and 7 also shorted. Okay, so the input is going to the NOT IC, that is pin number 1, and pin number 2 of NOT, and pin number 5 of NAND. Pin number 5 of NAND is connected. And the others connection will be same. Now we switch on and there is no needed Q bar also. Just open it. We get the output from Q, that is connected to pin number 11. Now switch on the power. Okay, this is our D flip-flop. If we give the 0, you can see the output is 0. You can see it. And if you give the 1, you can see the output is 1. So it satisfied the truth table. So it is our SR and D flip-flop circuit. Thank you.